Hi everybody, this is Miss Bufford, and this is video number 2 in our Acids and Bases unit over acid-base formulas and nomenclature. So your learning goals for this video are to be able to recognize acid and base formulas and to be able to name acids and bases. So let's talk about recognizing acid formulas first. So acids have acidic hydrogens that are listed in the front of their formulas. Acidic hydrogens are the hydrogens that are going to dissociate in aqueous solution. So just take a look at the formulas here for a minute, and you can see I have them highlighted in pink, that the hydrogens in the front are those acidic hydrogens that will dissociate into hydrogen ions in solution. Some acids don't lose all of their hydrogen ions, and some will. Some more information for you would be that if you notice the formulas, the first formulas up here, these all have one single acidic hydrogen. So these are called monoprotic acids, and they just have that one acidic hydrogen. If you take a look down here at sulfuric acid, this is a diprotic acid because it has two acidic hydrogens. And the word monoprotic and diprotic, that means one proton or two proton. And so remember, when we talk about hydrogen ions, a hydrogen ion is a hydrogen atom that's lost its electron, and all that's left is what's in the nucleus, which just happens to be a single proton. So that's why a lot of times we'll use the terms hydrogen ion and proton interchangeably. So in this case, monoprotic and diprotic is just talking about the number of hydrogens or the number of protons that are attached to these compounds. And then our last example down here, phosphoric acid represents a triprotic acid, where it's got three acidic hydrogens on front. Okay, so that's some information. And then the next couple slides, we're going to talk about how to name acids, and we're going to categorize them into two groups. We're going to categorize them into binary acids, and these are some examples of binary acids. We'll talk more about what those are in the next couple slides. And then oxyacids. Okay, and oxyacids, their formulas just contain oxygen. All right, so let's first talk about how to name binary acids. Binary acids are two-part acids that do not contain oxygen, and that's the big thing here, is that they just don't have oxygen in them. So some examples of binary acids would be these over here that just popped up onto the screen. I have hydrogen fluoride, hydrogen chloride, dihydrogen sulfide, and hydrogen cyanide. Those are the common names that we used when we learned how to name compounds like this before. But now we're going to learn how to give them their acid names. So what we want to do is we want to break these up into the ions that they're going to form in water. And you'll notice that they all have hydrogen in common, so we can't really use that as a distinguishing point. So we want to take a look at the anions here. So the anion is what's different between the different acids, and so we're going to use that to name these acids. So let's go ahead. I'm going to list out the names of all these ions, these anions. So we have fluoride and chloride and sulfide and cyanide. And if you notice, all of these ion names end with IDE. And so anytime you have an ion, an anion that ends with IDE, you're going to use the rule for binary acids to name those acids. And so what we're going to do is we're going to take the common nonmetallic root. So for these single atom ions right here, so fluoride, chloride, and sulfide, the common nonmetallic roots, if you remember, we used those before when we named compounds a while back. And then for cyanide, it's kind of an exception because it's a polyatomic ion and it doesn't contain oxygen, so it falls into this binary acid group, but it ends with IDE, so we're going to use cyan for the root here. All right, so we're just going to use this formula, hydroblankic acid, and we're going to enter the root into that blank space. Okay, so for example, fluoride or hydrogen fluoride would become hydrofluoric acid. Okay, we're just taking that, not that, those black letters, the fluor, and then inserting it between hydro and ic to make hydrofluoric acid. Okay, we're going to do the same thing for this chloride anion. So that would be hydrochloric acid. And the next couple ones have some exceptions. Sulfide actually ends up becoming hydrosulfuric acid. And so anytime you have a sulfide anion, you have to add a UR in front of the ending. Anytime you have a sulfur containing ion in an acid, you have to add UR before the ending. So this would be hydrosulfuric acid. All right. And then for this last one, remember we said that this was a polyatomic ion rather than a monatomic ion. So we have to use cyan as our root, not necessarily coming from this nonmetallic roots list. And that would just be hydrocyanic acid. So the only difference here, well, there's really no difference. We're just using the root just like we did before. All right. So we'll do some practice with these here at the very end of this presentation. All right, now let's talk about how to name oxyacids. Oxyacids are acids that contain a polyatomic ion that contains oxygen, that has oxygen in its formula. So some examples would be these over here. We have HNO3, HClO2, H3PO4, H2SO4, H2SO3. Okay, so those are some formulas that contain oxygen and acidic hydrogens. What I'm going to do is I'm going to do the same thing I did on the other side, and I'm going to break these into the ions that they're going to form in aqueous solution. So we can still see that they all have hydrogen ions in common, and they're anions now. All right, so again, we're going to look at the anion to be able to name these acids. And let's go ahead and pop the names up here for all these polyatomic ions. I have a small list of polyatomic ions down here at the bottom that you can use. But I'm just going to go ahead and throw these names up here for us. All right, so we have nitrate, chlorite, phosphate, sulfate, and sulfite. And so we want to notice that the names of these polyatomic ions either end in ATE or ITE. And for compounds whose polyatomic ion name ends in ATE, we're going to change the ending to ic, and then we're going to add the word acid. All right, so let's take a look at this first one right here. Nitrate is going to become nitric acid. Okay. Then for polyatomic ions whose name ends in ITE, we're going to change the ending to OUS and add the word acid. So instead of this being chlorite, it's going to be chlorous acid. Right? The last three polyatomic ions all have exceptions. Anytime you have anything that contains sulfur or phosphorus, you will have some exceptions, so that's a good thing to make a note of. So phosphate is going to become phosphoric acid. So it ends with ATE, and we still add that IC on the end, but before we can put that IC, we have to add an OR. So if you take a look down here at the exception that just popped up, it says when naming acids with phosphorus containing polyatomic ions, you must add OR and then add the appropriate ending. And the way that we determined that appropriate ending was that phosphate ends with ATE, so we're going to use the ic ending. Okay? And for sulfate, sulfate becomes sulfuric acid. So just like we did before, we have to add the UR, and this ends with ATE, so here's the rule, here's the exception here for sulfur containing polyatomic ions. You must add UR and then the appropriate ending, which is either IC or OUS. And in this case, because it ended in ATE, we're going to add IC and then OUS. I'm sorry, IC. So sulfuric acid. All right, and then this last one is sulfite. And remember, that's sulfur containing. So if we were going to do this, it would be sulfurous acid because we want to add that UR because there's sulfur in there. And then the sulfite ion ends with ITE, so we want to use the OUS ending here. So this would be sulfurous acid. All right, so make sure you keep note of those exceptions as well. So now let's talk about recognizing base formulas. These are very easy to recognize. They are ionic compounds that contain the hydroxide polyatomic ion, and they're soluble in water. So here's a big list of base formulas. You can see very clearly that they all contain that blue hydroxide polyatomic ion. Okay, so let's talk about how to name bases. So naming bases is really easy, and we've actually already learned how to do this, but we're going to just kind of review it here. Bases that dissociate into a cation and a hydroxide ion in solution are just ionic compounds. So here's 3 examples. We have sodium hydroxide, barium hydroxide, and ammonium hydroxide here. And I'm just going to go ahead and show you the ions they form in water. So they all have hydroxide in common, and they all have these metal cations. And when we name these, all we have to do is name the metal that's in that formula, and then the polyatomic ion, which in this case is hydroxide. So we end up with sodium hydroxide, and then barium is here, so barium hydroxide. And then, although this is not a metal, it's still a positively charged polyatomic ion. That would be ammonium. So we just say ammonium hydroxide. So these are really easy to name. Okay. Now let's go ahead and do a little bit of practice with naming the acids. Okay, so I have over here a list of acids that we're going to use to practice with. Some of them we've already named, but don't click back. We'll just keep on going. So I have HI right here, and what I want to do now is I'm going to go ahead and show you the ions that it breaks down into. And remember that I always base the name off this anion right here, and I know this would be iodide. And so if I know that it's iodide, it ends with IDE, then that is going to be one of my binary acids up here. So I'm going to use this first set of rules, ends with IDE. So what I want to do is I want to insert the root into that format right there. So I end up with hydroiodic acid. My roots are listed down here in case you forget them. Okay. So when you're naming acids, the stuff that I have on this slide is a really good thing to have if your teacher allows you to have notes on a test or a quiz or something like that. Either that or you just need to remember these. All right, so here are the ions for this next formula. We have a hydrogen ion and we have the sulfide ion. Again, this ends with IDE, but it is sulfur containing, so if it contains sulfur, remember we have to add that UR before the IC, and so this would be hydrosulfuric acid. Okay. The next one is going to break up into hydrogen ions and cyanide ions. And remember that the root for cyanide is cyan, and it ends with IDE, so we're going to use this first set of rules again. And this would be hydrocyanic acid. All right, and then this fourth acid right here, I have hydrogen ions, and then that is the carbonate polyatomic ion. And if we're looking for that, it's going to be in the first row of this polyatomic ion list down here, at the second one down. And we can see that the name of that polyatomic ion, carbonate, ends with ATE. So I'm going to look for the rule that says it ends with ATE. Here it is, the middle set of rules right there with the medium purple bar. And it says that I need to change the ending to IC. And this doesn't contain sulfur or phosphorus, so there's not going to be an exception for it. So I just need to change the ending from ATE to ICE. So I end up with carbonic acid, right? And then I have HNO2. I'm going to break that up into its ions. And NO2, I'm going to take a look over here at my list. That's nitrite. It ends with ITE. So my last set of rules here with the rule that says ITE, I'm going to change the ending to OUS. And just to be sure, it doesn't contain sulfur or phosphorus, so I don't have to worry about an exception here. So my name is going to be nitrous acid. And then this last one right here, I have it broken down into hydrogen and SO3 minus 2. Let's find that over here. This is sulfite. And so this one right here is it ends with ITE, so I'm going to use my last set of rules. And this one does contain sulfur, so I want to make sure that I add that UR and then select the correct ending, which would be the ending for ITE here. So UROUS. So this would be sulfurous acid. All right. I hope this video was helpful. Thanks for watching Buffered Chemistry. Subscribe to my YouTube channel for more chemistry help.